Hey, welcome everyone to our panel discussion today on the ocean's role in carbon dioxide removal. We're going to be discussing the challenges and opportunities of that concept. So as you probably know, humans are facing a global climate crisis due to the trillions of tons of CO2 that we've released to the atmosphere and oceans. Although our first order of business, of course, must be to ensure that we do everything we can to reduce greenhouse gas emissions, the IPCC guidelines are clear. Without permanent removal of carbon dioxide at a very large scale, specifically 6 to 10 billion tons per year, our goal of keeping warming below 1.5 degrees Celsius, which is what is needed really to avert climate change, will simply not be met. In general, carbon dioxide removal requires transferring carbon from the fast carbon cycle in the biosphere, atmosphere, and upper ocean to slower carbon cycles in the deep ocean and geological reservoirs. So the durability of this transfer does matter, as a carbon released back to the fast cycle too quickly will only contribute to more climate change. For instance, when we plant a tree, we do capture carbon from the atmosphere, but it's likely that carbon will return once that tree dies. Microbes break it down on the forest floor. Now, if we take that same tree and we transfer it to a slow carbon cycle, sinking it in the deep ocean, for example, we bury that carbon, it's considered permanently stored. So our battle, to durably remove and store carbon has really only just begun. Last year's total quantified carbon dioxide removal around the planet measured only in the thousands of tons. So a long way from the 6 to 10 billion tons per year that we must remove to keep climate change within that 1.5 degrees Celsius and avert global disaster. So there's multiple pathways that have been identified by the scientific community, by companies, and by policymakers. An example is direct air capture and mineralization in basalt, such as what's going on with Climeworks and Carbfix right here in Iceland. Each of these pathways has its own benefits and costs and drawbacks, and policymakers will need to evaluate all these pathways as additional information comes to light. So one broad approach that's been gaining a lot of attention, which we're here today to discuss, is the idea that we can leverage the ocean and natural pathways, carbon pathways in the ocean, to enhance carbon sequestration, to facilitate that transfer of carbon from the fast cycle in the atmosphere where it's causing the damage into longer-term storage reservoirs. The ocean is already one of the Earth's largest carbon sinks, sequesters 30% of the carbon that we release every year. So there's already a lot of carbon going to the ocean. Now, although this is good in the fact that it serves as a long-term reservoir for carbon, it's bad in that it also has its own set of problems. It's causing a process known as ocean acidification. CO2 dissolves in the seawater, makes it more acidic, and it makes it harder for calcifying organisms like scallops, lobsters, other shellfish, all important to Iceland and many other coastal ocean nations. It makes it harder for them to build those protective shells and skeletons. But there may be ways to allow the ocean to absorb carbon dioxide in a different form and safely store it without causing the negative effects of ocean acidification. So today we're here really to discuss ocean-based methods for carbon removal as a concept. Have open discussion with a broad range of perspectives with 5 leading researchers, environmentalists, and advocates for the ocean. And each of these experts is actively engaged in answering questions from different perspectives about how the ocean can remove carbon, and perhaps more importantly, whether we should even be using the ocean to remove carbon at all. So before I introduce the panel, I wanted to recognize Transition Labs for organizing and hosting this very important and timely event. For those of you not familiar with Transition Labs, they played a key role in advancing Iceland as a global leader in the fight against climate change. And they've done this by partnering with leading carbon removal projects from around the world and helping them to deploy and scale their solutions right here in Iceland and other places around the world. They work with different companies from different sectors, including everything from direct carbon removal from both the atmosphere and the ocean, to new solutions that indirectly remove carbon by reducing greenhouse gas emissions by improving, repairing, and replacing inefficient and dirty value chains. So to date, Transition's partnered with 6 different carbon projects, including 3 that specifically address the ocean. So today, we're here very fortunate to have 5 distinguished, like I said before, researchers, environmentalists, ocean advocates, who are going to provide different perspectives on ocean-based carbon dioxide removal. So first, introduce Jim Barry, second from the end there. Jim is a senior scientist. Dr. Barry is a senior scientist at Monterey Bay Aquarium Research Institute. His group studies the biology and ecology of benthic communities, and his goal is to understand interactions between environmental factors and biological adaptations that influence the survivability, growth, and reproduction of organisms and their distribution and abundance or ecology in the ocean. Jim also has led the work by Ocean Visions, developing an important document, the research roadmap for seaweed sinking as a method of ocean-based carbon sequestration. And this discussed key areas needed to evaluate the viability and impact of seaweed sinking as a carbon removal technique. Andreas Oschlies, second from the right, is the head of the Biogeochemical Modeling Research Unit at the prestigious Marine Research Institute GEOMAR in Kiel, Germany, and co-chairs the CDR-MER program. It's a new consortium, one of the biggest in the world, that's focused on questions about ocean-based carbon dioxide removal. On the end is Snjólaug Árnadóttir, an assistant professor of law at Reykjavik University. She's also the director of the Center for Law on Climate Change and Sustainability, and a member of the International Law Association Committee on International Law and Sea Level Rise. Her research focuses primarily on the impacts of climate change on the law of the sea, on environmental law, and on general international law. Her first monograph, Climate Change and Maritime Boundaries, was recently published in 2021. Hrönn Egilsdóttir is the head, in the center, is the head of Environmental Division at the Marine Freshwater Research Institute in Iceland. Through her, she has a dual role as a researcher and an advisor to government agencies. And in this capacity, she works on a variety of subjects, such as environmental and ecosystem change, the Water Framework Directive, and aquaculture impacts. Her scientific work mainly focused on the impacts of climate change and acidification on marine species, biodiversity, and ecosystems. And lastly, Birna Guttormsdóttir is the head of the Department for Environmental Quality, at the Icelandic Environmental Agency, where she's worked for 13 years, focusing on nature conservation, impact assessments, permitting for the industry, implementing the European Water Framework Directive, protecting the ocean, preventing pollution in the ocean, and fostering international cooperation on environmental issues. And my name is Justin Ries. I'll be the moderator of the panel. I'm a professor of marine and environmental sciences at Northeastern University in Boston. Like Hrönn, I work on the impacts of ocean acidification and climate change on marine organisms. I also conduct applied research in the field of carbon sequestration, mainly focusing on enhanced mineral weathering and ocean alkalinity enhancement. I teach courses in oceanography and global oceanic change, and in the U.S., I serve on the New England Coastal Acidification Network on their steering committee. All right, so welcome everyone. We're going to work through a series of questions that we've developed with the panel to discuss aspects of using the ocean, the challenges, the benefits, and what information we need to know before we really embark on this endeavor at scale. So the way I'll structure this, I'll pose a question. If any of the panelists would like to volunteer to speak to kick off the discussion, feel free. If no one speaks up, put someone on the spot. Or I think it'll work well. So the first question, we're all experts. We all study different aspects of the ocean. Maybe if you could each comment on what aspects of ocean-based carbon dioxide removal interests you as in your role as a researcher, advocate, environmental advisor. Maybe we could start.
Okay. Thank you for the question, and thank you for hosting this Transition Labs and chairing. Thank you. So what interests me the most probably, and why I got into this area, is because I started looking at climate change impacts on primarily boundaries in the ocean, and then just like went from there to just climate change impacts more generally to the ocean. And I think it's becoming very clear that there are rich obligations for states to respond to the pollution that is greenhouse gas emissions, and that they have rich obligations to prevent, reduce, and control the marine environment from this particular source of pollution. And just cutting down emissions clearly isn't gonna be enough. So I think just in order to meet these obligations, Ocean CDR may be just a vital tool really to address the international obligations that I've been studying. And we have an advisory opinion coming up soon from the Tribunal for the Law of the Sea, which is going to be addressing precisely these obligations. What is it that states need to do to address greenhouse gas emission pollution in the marine environment, so climate change impacts in the sea? And that's going to feed into this. And so I'm just like, hopeful that Ocean CDR may be one of the answers.
Again, thanks for being here. Thanks for organizing this. And my view of this is that none of us really want to do something like this to the ocean, but it's something we're in a corner now. We need to find our way out of that corner to mitigate climate change. I'm hoping that we can use a variety of technologies that using this integrated approach where we apply as many as we can in some sort of balanced way that kind of minimize the impacts of any one, so that we can get up to 6 to 10 gigatons per year, or whatever it eventually turns out to be the amount. So seaweed sinking, all kinds of activities that we've learned about, whether it's seaweed sinking, biomass sinking, ocean fertilization, or enhanced alkalinity. There's a variety of techniques that might be applied in different areas at scale. Some may be more impactful than others, and I think that's an open question. What's that right balance? Which of these are going to be both effective and least impactful?
Yeah, echo the thanks of the others to everyone. So I guess we give advice at the Marine and Freshwater Research Institute on the sustainable use of the sea. So I'm coming from it, coming to it from that background. I also have some experience in the carbon cycle. I think we should explore CDR. We should. I think we should not run before we can crawl. So my kind of take on this, and where I want to come into this, is like really help us make sensible decisions in the process of looking into these techniques as a potential solution to mitigate climate change, but basically coming from it from a role of someone who's advising on the sustainable use of the sea. So we cannot take too big risks. So this is kind of my interest lies there.
Yeah, thank you all. It's a pleasure to be here. My personal story is that 15 years ago, I was completely against all these ideas about messing up with the planet and called climate engineering, geoengineering. And I studied oceanography in order to protect the ocean, and that was my main target. But I got involved because the last iron fertilization experiment was run by a German research vessel, and there were protesters around and Zodiacs, and the government asked me and a few other scientists to evaluate it while the ship was steaming already. So we had 2 days' time to evaluate this experiment. Is it harmful or not? And that got me into this. So we ran a few simulations in the computers and found, well, might work, but this experiment we declared it harmless compared to natural variability, and so we thought it should go ahead if we are not concerned about any very short-term impacts. So the lifetime of these substances added was a week or so. But that got us really started to think about the role of the ocean in the climate change and the carbon cycle. And the second element, and then we had a few interesting ideas and tried to quantify what could happen in the ocean in terms of carbon, in terms of ecosystems, and to develop some metrics to assess it better. And then the next, personal tipping point was my role as co-chairing the UN Ocean Decade program on oxygen loss in the ocean, deoxygenation. And that's another threat which has been overlooked for a long time. The ocean is losing oxygen at a drastic speed, 2% over the last 50 years. So if we continue at that rate, there's no oxygen left in 2,500 years in the ocean. And that has happened a few times in the history of the planet. Mass extinctions were the consequence. A lot of carbon uptake as well, but for the ecosystems, it's really harmful. And the main cause is climate change, global warming. So that's another reason to stop global warming as quickly as possible. And we can't do that by just stopping emissions any longer if we want to reach climate goals. So each of us, global average, has a burden of 15 kilograms CO2 emissions per day, global average citizen. All of us probably has a lot more, 15 kilograms per day, so that's a lot of carbon. If we reduce it, maybe 90% can be avoided if we use all the technology, but still then we have 1.5 kilograms per day left per citizen, global citizen. And you can grow trees. If you want 1.5 kilograms additional tree, you need a lot of land, water, and so on, and you want to grow food. And then I think the ocean is probably our main hope that we can have, that can take up a large part of these 1.5 kilograms per global citizen. And there we have biological methods, seaweed sinking or so. I think that is attractive. We all like green stuff, but there are also chemical methods that sound less attractive if you think of your school chemistry or so. But they try to avoid ecological impacts, and that might be in the end turn out more attractive. So my hope is that chemical methods might be more benign to the ecosystems, or can be constructed in a way to be more benign. Modifying ecosystems, the green things, is often more difficult, and we understand ecology less than chemistry, I would say. But we don't have any option that works right now, or that can save the planet. So we have to expand the space of options. I think that's my key message. We have to test everything. Many things will go wrong. We have to be prepared. We need transparency to learn from each other, even from failed experiments. That's very important. 90% probably will fail. That's normal in science. But we have to communicate that we don't lose more time by others doing the same mistakes or the same, well, it's not a mistake, but it's just trial and error and best practices we have to do. Yeah, so don't forget chemistry, and don't forget deoxygenation, which will hit ecosystems. It is hitting ecosystems. We know about ocean acidification, which is a serious problem. I think deoxygenation is an even more substantial problem, longer lasting. And if you can't breathe, nothing else matters, no matter how warm, how acidic the water is, but breathing is really essential for all high trophic levels in the ocean.
So all those issues, great transition to the regulator.
Well, I guess, my interest in this lies in two perspectives. First and foremost, of course, the protection of our vulnerable ecosystem in the ocean. That is, my main interest. But then on the other hand, of course, dealing with those projects and the research that's going on, it is also interesting to see how exactly it fits into the framework, and see how we are actually going to tackle those issues. I mean, the climate crisis, of course, is very urgent, but we should also move with care when it comes to trying to solve problems that we have already created, and be aware of not creating problems in other areas. And,
Absolutely.
Yeah.
So some themes here. Trying to solve the problem. Our backs are in a corner, and we really have to act. We have to at least pursue solutions, but we have to do so, responsibly in a way to make sure we don't cause more problems than additional problem we're trying to solve. So, great points. Now, some of the audience members may only be partially familiar with ocean-based methods. So I was thinking, hopefully we could just kind of educate the audience a little bit about what some of these methods are more specifically. And I know not everyone is versed in the scientific side. So if anyone would like to volunteer to just discuss some of the methods, Andreas started to touch on a few, just in general terms for the benefit of the audience.
You too.
Oh, well, I'll start. And there are several methods. One that you've heard about here with running tide, and that's part of the reason, the main reason I'm here, is the idea that we could take some sort of biomass and sink that into the deep sea. And I won't talk about alkalinity enhancement as a component of that right now, but just the idea that we can move carbon from the surface to the deep sea. And once it gets into the deep water of the ocean to 1,000 to 4,000 meters or so, that water won't return to the surface and have the ability to outgas that CO2 into the atmosphere for perhaps 1,000 years, many centuries. So that's why we want to get it into that slow cycle down in the deep sea. So sinking biomass, and that biomass could be macroalgae that's grown either out in the open ocean, or there are many ideas to grow it in floating areas along coastlines, somehow package it and sink it. There's an idea just to capture crop waste from land all over the world, package that, move it out to the sea and sink it. So sinking biomass in one form or another is one method. Another is restoring ecosystems and maintaining ecosystems that then have more efficient function that can either buffer the change or cope with some of the changes in environmental stress that comes along with climate change, or help move that carbon from the surface to the deep sea by accelerating something called the biological pump. I won't get into details there, but basically some animals feed at the surface and move that carbon down, and you can sort of accelerate the rate that things move down using biology. Another method is that, Andreas, I'll let you describe it a little bit more if you like, is ocean fertilization. And I'm leaving out a couple others, but I'll stop for there because I don't want to dominate the conversation.
Yeah, ocean fertilization, that's basically like afforestation or land use management on land. That's what we farmers do on land. And the idea is to do a similar thing in the ocean, where we have a lot of surface of the planet, of course, 70%. Often not enough and nothing is growing because there's a lack of nutrients. There's always water and light, so that's what plants need, but nutrients are essential. And so you could add nutrients by shipping them there, distributing, similar as farmers do on land. And then iron is a micronutrient, which is also in all fertilizers that you use in your garden, on your, in your kitchen flower pots, which is often limiting in large areas of the ocean. So and that has a huge leverage. So 1 kilogram of iron added could possibly remove 1,000 kilograms of carbon or something. It's maybe just 100, but still it's a large number, and you don't have to move that much more. So the idea there is to use fertilizer to have blooms of algae. Part of those will then sink, naturally, or be eaten and sink as poo. But it's again a vertical transfer of carbon away from the atmosphere, from the sea surface, into the deep ocean, where it can be stored for a long time until the ocean currents bring it back to the surface. And that's an acceleration of the natural process. But of course, it's a huge messing around with the ecosystem. So something else will grow. It's same as in your garden. If you put fertilizers, you have everything there, but it's a different ecosystem. And the question is, do we want that? What are the benefits? Who decides? What happens if water moves around? Or the next, the fishermen in some other regions don't have the other nutrients left. So if you add iron, it's also nitrate and phosphate. The other major nutrients are consumed by the plants if they grow, and they may be lacking in some other places in the end. So it's a huge operation that's in this globally connected marine ecosystem that needs very good governance, needs monitoring and transparency, and decisions. Well, who decides how much we want to do? But these are the biological effects. It's, I think, similar on land. If one country decides to large-scale afforestation, You also change the water cycle, evaporation. You change even the climate because trees are usually darker than land, and so they absorb more solar radiation. So it will have non-local effects. Everything we need governance there as well, but it's probably more obvious in the ocean because we know it's moving around. Yeah, so that's the biological. If I still, no, I dominate. So there's these chemical methods, which is basically the natural thermostat of the planet on long timescales. That's all how major volcanic eruptions in the Earth's history were dealt with by dissolving carbonate, like coral reefs that the planet has today. They dissolve now because the ocean is so acidic, and also sediments on the seafloor, carbonate sediments dissolve. And that's the same you do in the kitchen sink. When you have there calcium carbonate, you put an acid onto it, and both disappear. So you clean when you shower. And the same happens in the ocean. There you have carbonate, and now we put an acid onto it, carbonic acid, and both disappear. So the dissolving carbonate neutralizes the acid, and thereby makes more space for new CO2 that can transit across the ocean surface into the ocean and thereby remove CO2 from the atmosphere. So dissolving coral reefs are good for the climate because they make more space for CO2 uptake, oceanic CO2 uptake from the atmosphere. And now if you don't want to dissolve coral reefs, you can just mine other rocks, which may be ecological less important, less valuable. Just to go to a quarry, use calcium carbonate, or volcanic rocks are even better. They dissolve faster, and they thereby neutralize carbonic acid in the ocean. And that's the chemistry. That's a natural process by which the ocean today would remove our climate problem, but it just takes a few 100,000 years. We don't want to wait that long. But that's how the planet has worked in the past. We had major catastrophes when continents broke up and huge CO2 emissions occurred. And the ocean in the end absorbed everything. Got a little bit more saline, so that's salts of the carbonic acid that are there. They are permanent storage. It's not in CO2 form. It's just carbonates, bicarbonates, chemically stable, benign as far as we know. We still have to. It's a change in chemistry and pH, so we have to study that carefully. There will be ecological effects. We think they are small, but we need to know this. But I think this chemistry it will rescue the planet in the end, but it's too slow for most ecosystems alive today. Therefore, we need to study, can we accelerate it in some responsible way? Where can we need regulations, governance to make sure that neighboring countries or other ecosystems are not affected by what we do in some place of the ocean?
So just to recap, three main processes we talked about. One being the burial, transfer of biomass to the deep ocean. It takes the carbon out of the upper ocean and atmosphere and puts it into the geological reservoir, marine sediments, or deep in the ocean. We talked about chemical methods, dissolving limestones, reacting, essentially weathering of basalts, like your country is made of, and all their mafic and ultramafic minerals like olivine, which you may know. And that releases the alkalinity to the seawater. It does two things. It offsets the ocean acidification and allows more CO2 to go into the water by converting the CO2 that's there into a different form known as bicarbonate, which is stable and has a longer residence time. And then we also talked about iron fertilization and nutrient fertilization. And that really is almost a form of biomass burial because you're enhancing the natural growth of algae and plants in the ocean and supporting their transfer to the deep ocean, the slow carbon cycle. We spent quite a bit of time on the science. Maybe we could switch gears, jump ahead a little bit in the questions, and talk about the policy, ethics of ocean-based carbon dioxide removal. To start this part of the discussion off, I wanted to pose to Hrönn, Snjólaug, and Birna, what do you think the key policy issues are that are most relevant to ocean-based carbon dioxide removal?
Well, I can start, yes. Well, I think this is a really important issue. I mean, the policy discussion hasn't started yet. So we need to make the framework around those methods in order to be able to take the best decisions. And in the meanwhile, of course, we have to discuss, you know, like we discussed earlier, what is the cost of those methods? Are we really are we willing to pay the price if there are any risks in stake? That is a question that has to be asked, and we need to answer it as well during the policy discussions.
And when you say costs, not just the financial costs, but the
I'm
environmental
talking,
costs.
the ecological cost. I mean, we have to know the risks, and I think that is, you know, the baseline that we would have to discuss. What are the risks, and what are we actually willing to pay when it comes to those risks? But then, of course, I mean, the legal framework as it is today is not ready, and it's not ready in Iceland. It's not ready in an international venue as well. There is a discussion around the London Protocol, of course, you know, about guidelines and how to tackle those kind of projects or marine engineering. And that is something that we have to take aboard in these policy discussions and decide the roles of each entity, of course, and who is responsible for the permitting, who is responsible for validating the monitoring, and who is responsible for each part of this whole procedure, which are those methods that we're discussing here today.
Yeah, so building the framework, because we don't even have the framework in place, let alone the specifics of what's in that framework. Snjólaug.
Yeah, thank you. So I think there are, I mean, several hurdles here, and maybe I would like to mention both like the lack of policy that we have now, and maybe if I focus a little bit also on Iceland, if that's
Oh, absolutely.
yeah. So maybe here lack of policy, but also some like conflicting legislation and approaches even, and which I think also then relates to the fact that we're just not clear on the ideology, I think, and coming from a legal perspective here, an environmental legal perspective, we've always had this, I mean, the core principle of international environmental law and domestic environmental law is just to do no harm. Just don't interfere with the environment, just do nothing, hands-off approach completely. And but now we're faced with a major pollution, major consequences in the form of climate change, and we also have an obligation to respond to those. But so it's kind of problematic in even forming any policy or making decisions on this, because we're supposed to do nothing, you know, just don't touch the sea, but it's like on fire, or you know, it's we have a major problem that we also are obligated to address. And how are we gonna then, like, what is actually the pollution? Is the pollution that we want to address climate change, or is it ocean CTR? You know, and both can be pollution, and both is something that the policymakers need to address and regulate. But it's hard to make those decisions. And maybe then a little bit more than on like in Iceland. I mean, we have like in the climate action plan, there's specifically it talks about, you know, forestation and land use change and various things, but nothing on ocean CTR. And I think also just internationally, these instruments, like, I mean, the climate regime hardly touches on the ocean, even though that's, you know, bigger part of the planet and all of that, biggest carbon sink, etc. And I mean, carbon, I'm bad at this, the terminology when it comes to science, but you know, enhancing carbon sinks generally is of course encouraged, and we pretty much everyone likes, or okay, no, that's not true, but generally speaking, forestation is seen as something, you know, a good tool, and I just think it's just so underdeveloped, any sort of discussion and policy on the CTR in the ocean, because like in my mind, and again, I don't understand the science here very well, if at all. But like in many ways, this resembles at least the ecological approaches or biological resemble like forestation. And yes, that, like you mentioned, that can impact the whole cycles with, you know, the water absorption and all of these things, and just the pre-existing ecosystems where you start the forestation. And that seems to be risks or, you know, threats to certain ecosystems that we're willing to accept. But we're very afraid of the potential risks in the ocean, even though we know the risk of climate change. You know, there we know the risk and we know we need to respond. So, okay, yeah. So lack of this hasn't been thought out, and we need a clearer, just clearer regulation. And so, and also with the conflicts, maybe in approaches or policies, like in Iceland and also internationally, we have the climate regimes telling us, obviously, to, you know, go to carbon neutrality, and we know that the IPCC reports are telling us emissions aren't, you know, cutting emissions isn't enough. But then we have, yeah, like the rules saying that we should generally allow marine scientific research. The Law of the Sea Convention talks about that, and the domestic maritime zones law, and we should protect the marine environment, and we should respond to all forms of pollutants, like greenhouse gas emissions causing climate change. But then also the Law of the Dumping Convention and Protocol, and we have that also implemented in domestic law here, saying that, you know, all forms of dumping is prohibited. So conflicts, and this needs to just be thought out, everything more clearly. I know that the Sapin Center on Climate Change at Columbia University has developed model laws that could regulate this. And so there are different things that should be, or that they're recommending, like thinking more about, you know, just defining the research and thresholds. And I think they referred to it as like a death point or something, where you would, like, if research has been permitted and then we see some consequences that we weren't expecting that are too serious, and then you pull the plug on the project. So this clearly, just generally in the international community, like, you know, that domestic laws haven't been developed sufficiently, but that's what we need.
You raised a great point, because the practitioners of carbon sequestration now are not only inventing the technology and developing the technology, but they're also dealing with all of the legislative side, the policy side, which does not exist. So it's equivalent to, you know, a car company trying to build a new type of car, but at the same time trying to convince the government that driving is legal, that the car can even be used. So it's a big obstacle to innovation and development. Maybe we can transition to Hrönn, because she is in a unique position of being both a scientist and an advisor to government agencies, advising on a framework which doesn't exist. So the challenges there that you could probably comment on.
I think you made a good point with the car. So trying to convince the people the car is working and running. The car isn't working and running. I think this is a key point here, that all of these methods are in a very early stage in their development, very early stage, like really early. We don't know if they work, like we don't know how scalable they are. I think this is the biggest issue. If you scale it up, like to something actually impacting the climate or taking up enough CO2 to actually impact or reduce climate change, then it's really hard to see you not causing massive ecosystem change in the areas you're operating. So scaling is a huge problem, like ocean alkalinity enhancement. So there's a lot of mass balance budgets that you have to think about. How much rock do you need to put in the sea to make ocean alkalinity enhancement, and how much rock do you need to put to, you know, make the drawdown something that is a drop in the ocean, even, you know, with regard to CO2 coming out or pumped out into the atmosphere. So there's a lot of rock there, and it's been estimating it would cost like more than per year just mining and dumping or putting the material into the ocean. It costs probably more than the financing of the U.S. Army every year. You know, it's like, so we have to think about the numbers. We need to think about how much it costs financially. Are we putting the money where it's best spent. I think this is a key question as well. Are we, happy with the risks? And I think I'm very pro the research. I think we should be doing research on this, definitely. But we are at a very early stage. And yes, we need to think about the legislation, but we shouldn't be operating at that level yet. We should be doing the research. So yes, preparing the legislation, do all of that, but we should maybe, my key point here is we should kind of learn to crawl before we start running here, right? We should know the risks. We should know the ecosystem risks, and also we need to make sure that there is enough to gain from these methods. That it's actually where we want to put the focus of our heads or minds. Do we want to put the focus there, or do we want to focus the funding and our minds somewhere else? So there's a lot of buts or ifs and potential and not potential. What I want to mention here is yes, we have global climate change, but my kind of view of CDR methods is more along the lines of local mitigation potential. So if we have an area that's very vulnerable to ocean acidification, maybe we can look at ocean alkalinity enhancement locally in that area. I think this is a more potential there than maybe solving the whole climate change here, because of all these mass budgets. How much nutrient do you have to put in the sea for it to actually draw down enough that it makes sense? So yes, we should be doing the research, but it should crawl before we can run here.
Yeah. So it's a little bit of a chicken and egg though, because in order to do the research, you need even some legislation governing that, because a lot of the legislation that governs the scaling even governs the ability to test it in a smaller capacity. I think we do need some framework just to permit the experiments that will allow us to build a framework for larger scaled up operations. Jim.
So I agree, for local action, there might be some things that would work on a local scale, but I see that as a different class of problems where we're talking about the global solution to climate change or mitigation of climate change. And whatever that form is, whether it's ocean acidification, or ocean fertilization or biomass or all of it, it probably will represent large perturbations to ecosystems. It's going to change ecosystems. The purpose of fertilizing the ocean to move more carbon down is to change that ecosystem so that it accelerates more carbon moving down. So we have to decide, probably through modeling and initial experiments, whether we feel that those changes that we're going to see are worth the risk to the benefit that we may see in the reduction in the amount of warming we're going to see in the climate system, and as well as how that plays out in local systems. So we need legislation that will allow us to start to move forward with some of these. And I think Running Tide's a great example, because they're out trying to do what I see as the right thing. They're not just trying to make a buck, they're trying to do this the right way and trying to make sure that they verify how effective is carbon sequestration going to be from end to end, from the forest right down to the bottom of the ocean. And I see the opportunity for many other people that might be or small companies that decide, let's get into the CDR business and we can make a buck selling carbon credits without really considering what the process is going to be that's required to make sure that that's an effective way. It has the least impact that you might be able to hope for. So I'll stop there, but this is going to be changes to ecosystems, ocean ecosystems.
Yeah, I think research is needed, but usually scientists, you think they work in a lab and in some remote places. Also, I think what we need is really field experiments here, because we cannot simulate the marine ecosystems on computers. We cannot simulate it in an aquarium. We have to understand it in the real world, and that's where all these conflicts arise, of course. So we need good governance of research. And I think Iceland here is a prime example. But well situated, it's democracy. We can have good governance systems, and that can play a role model that you open up in a transparent way to research. And I think it has to be decided on case-by-case studies still, and we have to learn. But going this way, I think that's excellent. And like my country, Germany, is very restrictive. It's just we cannot even apply to do field experiments. It's not allowed to apply, and so because protection of the environment has such a high value there. But that's a showstopper if we have to remove these 1.5 kilograms of CO2 every day. If that's the most optimistic scenarios, that we avoid 90% of our emissions, and then everybody of us, the world population, will have to remove that amount in 25 years only, and we don't have a plan how to do this. So we have to learn quickly, and I think that's what I really like to see, that you're moving forward and well, preparing opportunities to study things in nature and well, have running tide or similar startups that do all the entire, well, cradle to grave system. What can go wrong? What do we have to improve? What might be a showstopper? We have to learn that quickly, and we need transparency and well, and hopefully democratic decisions. There are some states on the planet who do a lot of research as well, which we do not see, which we cannot understand, which is, I think, lost opportunities in many cases. So we should lead by example to do that as transparent and quickly as possible.
That's a great transition from the policy side that we've been talking about, this need for a framework, this need to balance cost and benefits, but to provide a framework to just start to build the knowledge in order to evaluate the risks, which is going to allow us to plot the course forward, scale things up, build a larger framework, or divert to alternative strategies. I'd like to spend a little bit of time just talking about the ethics, from a legal perspective, even from a personal perspective as a scientist. There's essentially two sides to the ethical argument. There's they're not even two different sides. It's almost a paradox, right? We have the general ethical principle to do no harm. And a related principle, the precautionary principle, always to act in the most conservative manner to achieve your goals. On the other side, though, there is a generally universally accepted ethical principle that humans have a duty to intervene. If you pass someone in distress and you need to help them, if you're in a vessel at sea, as important part of Icelandic culture, one vessel cannot pass another vessel in distress. It's against the law. So there's an ethical and even a legal duty to intervene. So maybe to get thoughts on, how do we balance the do no harm ethical obligation with our duty to intervene in a crisis?
I mean, I talked about this a little bit earlier that we have the no harm principle of environmental law. That's a binding principle that you should just generally not interfere to cause harm. But once you have interfered, then also you should respond and clean up. So, legally speaking, these are just like really clearly two contradictory kind of principles, and onto just like the Law of the Sea Convention, which is a constitution for the oceans and set that general framework for everything. We have these obligations to reduce, prevent, control all forms of pollution, and also to protect the marine environment. And then this means cleaning up after the greenhouse gas emission pollution and also prevent dumping. So I think it's good to take into account there also under like a precautionary approach. What are the risks? What are the known risks and potential risks? And there, I think, I hope I'm not becoming too biased in favor of action, but we know the risks of, not doing anything to respond to climate change. So in my mind, at least like as much research as we can safely conduct to try to understand whether this one solution to the harm that we know of can take place. And, the difference between also the capture of carbon and on land and sea, I think we should apply the same ideology more.
You view the two ethical issues as not a true dilemma, but as compatible. We have a duty to intervene, but once we do so, we do it to minimize the harm that we cause. Any other thoughts?
I guess I have a thought about that because I grew up surfing on the California coast, and my goal was to continue studying oceanography, and maybe I could get a job doing this. And I ended up having a wonderful job, but I love the ocean. I want to protect the ocean. And I guess I view this problem as the London Convention is both inhibiting us and in part enabling us to try and do something about ocean acidification and all of the other things that are going on with climate change. But the impediment to learning about how we might be able to deal with ocean fertilization or biomass sinking is in part not accepting that we have already perturbed the planet so much that we're in a crisis and we have to deal with it. It's kind of like you have your water heater in a closet and there's water leaking out under the door and you're afraid to open it to figure out how you can fix it. And that's what we need to do. And Iceland has been brave enough to say, yeah, let's open that door and take a look and begin to assess that problem and see how it can deal with it. And that's, in a sense, what these new experiments are. They're the start of letting us figure out what works, what won't work. And by just saying, there's no problem with climate change, we can't hurt the ocean, that just won't ever work, I guess. And that's my personal view on why we need to move forward.
Yes, I share this view. Well, I personally, I want to protect the ocean, protect the planet, protect everything. But ethically, I don't think that is a robust metric, since it's ethics. It's, in my understanding, concerning people, and so justice. I think that's my highest. Well, I think probably maybe the most robust principle in my very naive interpretation of governance schemes, but it's intergenerational justice, so to leave our kids and grandchildren and so on a planet where they can live. But it's also justice right now among those who benefit from CO2 emissions or energy production, and those who just get climate impacts and don't benefit or haven't benefited the last few years. So we have to there's clear ethics, ethical principles that apply there. Not giving nature or some organisms, microbes, any higher ethical value than humans. But this justice, I think, can lead to the same principles, that we need governance, that we have to protect some ecosystems more than others in order to provide food, provide living conditions, and that should be. It's more anthropocentric system, which probably can be understood by most people on the planet, by politicians, its voters. So that might work better in the end if we want to use ethics.
Yeah, I guess my view on this is, of course, when we are protecting the ecosystems, we're also protecting humans, because we depend on the ecosystem, so it goes both ways. But I think in all of this, we kind of somehow have to have the discussion about the ethics in all of this. And maybe there could be some kind of a solution of creating some kind of a code of conduct about, what are we really going to do about those issues. And then I'm just trying to think on a practical side, something that people could agree on when we know the risks and the stakes, so to say. And I think also, because it always comes back to the framework and the policy making, that somehow in all of this we have to start that discussion and take the ethics from the beginning in that discussion, open discussion about how we are really going to deal with this. Because as there is a saying in Iceland, í byrjun skaltu endinn skoða. So you should always, before you start, you should consider how it's going to end. That's
very good advice.
Practice it more often, maybe.
That's a great idea. Code of conduct as a precursor to the legal framework. And I think there are some works being developed on the academic side, proposing codes of conduct that people are discussing. So it's a good starting point. So we do have a parallel session going, not a parallel, but a session starting at 10 at the Climate Day that I know a lot of the attendees want to attend. So I want to respect everyone's time. And before we break up, though, I wanted to provide the opportunity for the audience to ask a couple questions of our panel. They're all together.
It seems like one of the most critical things that needs to happen in order for science to advance is for people to agree on what is evidence. So to actually categorize what type of impacts will be important, there needs to be a consensus on what level of ecosystem erosion or dissolution is acceptable, and how do we begin to measure that? So before policy gets made, before researchers start collecting data, it seems like one of the key things that people have to agree on is what is an acceptable metric and level of loss. So for any discussion to begin at the political or scientific design level, what is an acceptable level of reduction or loss, and how do we measure that? Is it best to study eDNA? Is it best to study species diversity? That type of movement, it seems, needs to be a key foundational event to happen, at least to me as an evolutionary geneticist, before any further action is taken. Would the panel generally agree with that sentiment?
No.
Go in the middle, it depends.
Well-balanced panel.
Well, it's a difficult question to answer, because I think we would all agree that we have to try and identify what the risk is, and what does risk mean in terms of how much of a perturbation to a particular system is acceptable. Now, that is both a scientific and a societal value question. So I think we'd have to talk about a particular issue. So take ocean fertilization. If we were going to fertilize the ocean and it's going to lead to a shift in either the diversity or the level of abundance of a particular fishery, then maybe we could get a handle on that, ideally, which may be difficult, and then together make a decision about how that would what's acceptable in terms of risk. The way that I think this has to work is science has to be out there providing some evidence about what those changes may eventually be with any particular method that's being used. And the transparency that we've heard about, that's critical, so that not scientists, but everyone can be involved in making decisions about what their future and how it will be impacted by these methods is going to eventually play out. So it's not a scientist saying, oh, this is acceptable. It's society saying, this is what's acceptable. It's the fisheries, the people that depend upon those resources. So it's a very wishy-washy answer, but we need to have some guidelines. And I just can't say it's 10% of scallop abundance or something like that. It depends.
Yes, please do.
I have a question regarding now ocean fertilization has come up in a lot of the talk here. And we do have a model system there since 15 years ago when iron fertilizations was promising. And 15 years later, we're not fertilizing the ocean with iron. And it mostly is because of the damage that will be done to the microorganisms, or lack of carbon sequestering also in this method. And I'm thinking, are we facing the same for ocean forestation, that it will take us 15 years from now with labs all over the world doing science? Because for the iron fertilizations, labs all over the world were doing science on this. Is this, the timeline?
Hopefully not, but might be, yes. I think, well, iron fertilization was still a niche aspect. There were a few groups. We had about, I think, 13 experiments in the field. And they showed, yes, it can work, has a huge ecological impacts, and it doesn't work as well as we had hoped. Now it's coming up again in some corners. Personally, I don't think well, the leverage is still too small. You would have to change the entire Southern Ocean ecosystem. But still, it could have climate benefit. Right now, I think we have learned from those experiments a lot, scientifically, but also governance-wise. The London Convention was installed, basically, or the geoengineering research part, because of those iron fertilization experiments. It's still the best role model we have. And I think we have now to expand that further to other approaches, and then be able to look at all approaches much more efficiently. We know what went wrong, communication went wrong, and many things, and the governance schemes were not in place, and now we are better. And next year we will be even better, but we have to do something. We can't do nothing. And I hope that within, maybe, well, we have to know within a decade what could work, at least, since then the scale issue will be the next huge difficult issue, how to scale it up, how to govern that. And that takes another maybe decade to do this for this, well, gigaton challenge that we will face by mid-century.
And the climate, the social climate is very different than 15 years ago. There's a lot more will to act. There's a lot more urgency because more people are aware of the effects of climate change, seeing the effects of climate change, and a more willingness to act. So I don't think we're going to get caught in that same trap that we were when there was less of a will to act. But we do need to break. I just wanted to quickly wrap up, and this is a very interesting discussion. Thank you all for attending. I think it's safe to say that we all agree there are a large number of uncertainties, but that CO2-induced climate change is a major issue that we have to deal with. We have an ethical obligation to at least try to find a solution. And it's really it's an Earth system problem. It's an Earth scale problem, and Earth scale problems require Earth scale solutions to solve them. That's something we have to keep in mind. And I think there's no silver bullet. There's no single solution to this. We have to pursue emissions reductions. We have to pursue at research stage all the possible opportunities, assess the risks, determine the benefits, and then allow the world to make the decision on which of those avenues to pursue. I think one of the most important things that comes out of this, even though there is a sense of urgency, we have a moral obligation, ethical obligation to act, and we are seeing the effects of climate change in terms of glacial melting, sea level rise, ocean acidification, global warming. Any action we must take must be done responsibly and with the necessary due diligence to prevent causing more damage than what we're trying to solve. I think we all agree on that. And ideally, to promote ocean health, find solutions that actually have benefits to the ocean. And those should exist too. There should be some positive benefits to these things, not just negative benefits. So let's end today by thanking Transition Labs for organizing and hosting this event, and our distinguished panelists, Snjólaug, Hrönn, Andreas, and Birna, for participating in this really timely and important discussion on ocean carbon removal. Thank you.
Thank you all.
Thank you.
Yeah, very much.